So hi, I'm Peter Flynn. I'm one of the engineers on the Brackets team, and I'm going to talk a little bit about Brackets architecture, or architecture. Um, and this is sort of fast-paced. There's a lot of material here, so it's sort of expected that, to really make use of this stuff, you'll probably need to do some further reading, either of the source code or online about some of the different third-party libraries that we use. So um, that said, also before I jump into it, I want to make a quick apology. Some of us on the team are cooler than others. I'm on the lame side, and also Ty, who spoke before me. So the lame people use PowerPoint, and we know that all the cool kids use like Reveal.js and stuff like that. So you'll see some presentations in that and some in PowerPoint, and I apologize for being lame. So yeah, with that said, let me talk first about the really high-level architectural organization of Brackets. Then I'll talk about how the UI is structured a little bit, and then I'll talk about some of the sort of abstractions and classes that we use. So at a very high level, Brackets is basically just a web page. It's JavaScript, HTML, CSS. It's built with all these great web technologies that we can make use of, and it's because it's really just a web page. It happens to be in an app shell that's a little bit different from a traditional web browser, but it's basically a web view. And so at a very high level, this is the way it's structured. There's an app shell, which is a web view with less Chrome than a browser and with a few extra APIs. And then inside there, we have the core of Brackets is really JavaScript and HTML code. So the web view, like I said, it's a little fancier than a browser in some senses. The core is the Chromium version of WebKit. It's wrapped in a wrapper called CEF, Chromium Embedding Framework. And on top of that, we've added a few extra APIs that we use for things like accessing the local file system. That's that green box there, the Brackets app code. The JavaScript and HTML code that constitutes the bulk of Brackets, it talks both to the standard JavaScript APIs that WebKit provides, as well as talks to these special additional native APIs that we've added. And those APIs, the native APIs, those are all treated as asynchronous APIs. The reason for that is that in the future, you could imagine a world where the Brackets JavaScript and HTML portion is running in a web browser, and those back-end APIs are actually running on a web server somewhere with asynchronous communication between the two. So even though that's not really a strict requirement in the current situation where they're both running in the same process, we want to keep the door as open as possible for a future where they're actually running on separate systems like that. And for that reason, we treat all these APIs as asynchronous. So zooming in a little bit on the JavaScript and HTML side, we have a bunch of these sort of core pieces of technology we use. So we use jQuery for a lot of our UI, as well as we use jQuery plugins like JSTree for different pieces of our UI. We use Less, which I'll talk about in a little bit. That's sort of a CSS enhancement framework. And we use Bootstrap, which is on top of Less. That's a framework put out by Twitter that's sort of a scaffolding for building up your CSS structure. CodeMirror is a JavaScript code editor, basically UI widget that we use. That's sort of the heart of the code editor. I'll talk about that a bit as well. And we use RequireJS to modularize our code. RequireJS is an implementation of CommonJS modules, essentially. And that lets us split up our JavaScript code into a series of files that can basically call out the dependencies to each other and can expose a public API and then have their own private methods as well. And so those green boxes there, it's the series of modules. We have a whole bunch of JavaScript files that contain the main source code for Brackets. You can think of that sort of as analogous to classes or packages in a lot of other programming languages. So about modules, there are a number of different frameworks for doing modules in JavaScript, and they're all a little bit different. So I'll talk really briefly as a one-slide micro tutorial about RequireJS. This is basically like what a Hello World module would look like. So you see at the top, we have this call to define, and then the entire rest of the file, basically, your entire module is wrapped in this anonymous function. And that basically lets you keep all of that stuff private. You're not injecting stuff into the global namespace. That function has these two arguments, require and exports, which are key objects that you use to basically interface with the rest of the app. So the require argument there is how you get at other modules. And you can see that at the top of this file here, where we're importing essentially the console module. So you call require, you pass it the name of the module that you want as a string, and that actually will go get the JavaScript file and make sure it's pulled into your page. And it will return you an object that represents the public API of that module. So we get this console object back. And then you can see in the middle part here, you have the code for your module. You can use these other modules you've imported just as if they were right there. And then at the tail end, the footer of our module is where we actually declare our essentially public API that other modules can then use. In this case, we just have this one method, say hello world, which we're adding to the exports object as a new property. And so that exports object, that turns into the object that other modules see when they import this module. So for example, here you can see the console module has a print method. When, if you're in the console module, you would actually see in that export section, you would see exports.print equals whatever function implements print. So that's RequireJS in a nutshell. CodeMirror is another really core piece of the technology that we use in Brackets. CodeMirror is an existing open source project that was not made by the Brackets team. It is essentially a lightweight, streamlined editor widget built in JavaScript, runs in the browser, etc. It's not a full-fledged editor tool, so it doesn't provide things like save and load. It's really just the editor widget. It has syntax highlighting, it has basic keyboard gestures, but that's really it. It's designed to be lightweight and compact. So it doesn't have doesn't provide a model that's separated from the view. That's something that Brackets has to add on if we want that. And we're sort of halfway through the process of beginning to hoist out a separated model. And I'll talk about that a little more in a few minutes. CodeMirror also provides virtualized scrolling. So if you have a huge file, like 100,000 lines of JavaScript code, it's not dumping all that text into the DOM. So for efficiency, it only renders a few lines around the visible area. And because of that, when you're typing, the actual focus is not you're not looking at like a text area or a content editable div. You're actually looking at this virtualized rendered text, and your keyboard focus lies in a hidden text area that CodeMirror just uses for getting input, basically. So Brackets has its own fork of CodeMirror, which is up on the Adobe GitHub page there. And we have a number of patches we've made to CodeMirror, and we're in the process of actively working to get those patches submitted back to the original upstream CodeMirror repository. And then one other thing I want to mention about this sort of key technology we're built on top of is Less. So how many people are familiar with Less already? What about Bootstrap? Cool. Okay. So for anyone who's not familiar, again, one slide micro tutorial. Less is basically like CSS on steroids. It's a CSS-like language that sort of compiles down to CSS. So it provides really cool things like mix-ins, which are basically functions you can call that generate a blob of CSS. So you can see like the rounded corners. It's sort of like a macro here. Spits out the different border radius pieces of CSS. You can have variables. You can have math on variables. So you see here dividing a margin by 2. And then you can do nesting, which is a nice way of kind of keeping related stuff together rather than, you can see on the right-hand side there, the CSS, where you have to break all those rules apart, sort of flattening down the hierarchy. So that's Less. Okay, so before I get into the sort of more abstract parts of the Brackets architecture, like object models and all that stuff, I just want to walk through a few slides talking about the more visual part of the organization. And in fact, I'll start with just sort of a little roadmap of the different parts of the Brackets UI, what the terminology we use for them is, because often, in code, you get this situation where the name used for something in the code is not the name that you expect in the UI, or it's not what it's labeled as in the UI. And so that can be a little confusing when you start delving into the Brackets code. So on the left-hand side here, we call that the project panel. We have a sidebar view module, which manages some of the UI layout there. We have a file view controller module, which essentially arbitrates which of the two list UIs in that panel own the selection highlight at any given time. Those two pieces of that panel are the working set on top, which Ty mentioned briefly, and then we have the project tree or the folder tree on bottom, which lists all the files in the project. The working set has a working set view module that owns the UI. The model that maintains what the list of things in the working set is owned by a module called Document Manager. On the on the bottom of the left-hand side, we have a module called Project Manager that owns that UI, and it doesn't really have a model, or the model's kind of mixed up in the UI, so that part is a little bit less clean. The central area where the big editor is shown, that's owned by a module called Editor Manager, and also maybe a little less obvious, that title bar area up at the top that says what file goes with that current editor, that's also owned by Editor Manager. That editor that fills the whole area, we call that the main editor or the full-size editor, and that's in contrast to the smaller editors that you see, for example, down here inside the inline editor that's been sort of torn open there. Editors are represented by an object called editor, which is essentially a wrapper around CodeMirror, and the backing model for that is something called document. I'll go into editors and documents in more detail shortly. So then this region here, when you open an inline editor, we call that an inline editor. It has a bit of a class hierarchy around it. So inline widget is sort of the base class. That's basically any piece of UI that can get injected into a larger editor like this. Inline text editor is a subclass of that, which introduces the concept of there being specifically a text editor inside that piece of UI. And then multi-range inline editor is what you actually see here in the screenshot. That introduces the idea of this list on the right-hand side, which has references to multiple snippets of code in different files, and then clicking in the list, switching which piece of code is visible in the editor. And that list, the name can be a little confusing. In some parts of the code, we call that the rule list, which is referencing the CSS inline editor that was the original implementation. Sometimes we also call it the related area, which is a little bit more of a generic term. So all that UI, I'll go back to the screenshot for a second. Basically, all the UI here that's static, that's not sort of dynamic pieces being generated based on the user's data, what's open in the project at the time. All the static UI is hard-coded right now in our Index.html file. So a really high-level overview of that organization. You can see we have the project panel. Then we have another div, which is essentially a vertical stack of the toolbar menu bar area over top of the editor area, and that's over top of any bottom panels, which are hidden by default. So the screenshot here, you don't see any. But for example, if you had committed a sin against JSLint, there'd be that JSLint error panel that pops up, and that becomes visible. And then at the very bottom, we have a series of templates that basically contain the UI for different dialog boxes that pop up. So right now, that's all lumped into one big file. We are definitely interested in using templating stuff more in the future so that we can, A, begin breaking up this file into different pieces, and B, sort of begin unifying the way we declare UI that is static versus UI that's dynamically generated. So we haven't done that yet, but we're definitely interested in moving in that direction. One other quick note here, a lot of the vertical layouts in brackets use box flex, which is sort of still a little bit of an exotic piece of layout CSS. We're using the original version of the spec, which is implemented in the WebKit that we have rather than the newer version of the spec. So at some point, we'll have a day of reckoning about that, I would expect. So with that said, let me talk about some of the more abstract portions of the brackets architecture, less visual, more model and such. The first thing that's useful to understand, and this is, I say core here because this is really the stuff that almost no matter what you're doing in brackets, whatever kind of extension you're writing or whatever you're hacking on, this is stuff that's pretty much essential common knowledge for almost anything you'd want to do in the brackets code. So the first thing that's really important to understand is how user actions and user gestures are handled. Almost every action the user takes flows through this simple sort of command flow that I'm showing here. So keyboard shortcuts are handled by a module called Key Binding Manager. Clicking on a menu in the menu bar is handled by a module called Menus. And then any other piece of UI can also go through the same workflow. So for example, clicking on a list item in the working set. All of those basically flow through this dispatcher called Command Manager. And in spite of how giant and intimidating the box looks on that slide, it's actually a very, very simple module that is very, very little other than just a map. It's mapping command IDs, which are just string constants, to functions, which are the handler for that command ID. And that's all it does. So all those modules on the left here, these essentially just say, hey, invoke the command with this ID, and Command Manager goes and looks up the function and calls it. And that's the handler on the right here. So that's pretty simple. Let me show very briefly how you actually use this stuff in the code. If you want to add a new command, the first thing to do is declare a constant for it in the commands module. It's just a listing of constants. And then in your module that provides the implementation for that command, you basically call command manager.register, which is just adding to the mapping this command ID to function mapping. And typically the way we organize our code is those command registrations are down at the bottom of the module around where you're doing the exports for the RequireJS stuff. Once you've added a command, you want to expose it in the UI, of course. So I'll show how to do that as well. And by the way, I should add that this is stuff that we're sort of looking into this in terms of exposing stuff in the UI. This is stuff that we're currently talking about changing to make it more extension friendly. So take this with a grain of salt, and we'll have a wiki page that documents this stuff, so it will continue to evolve over time. To add a menu item, you essentially just change these two files. You change in Index.html where the UI is actually hard-coded. You just add a new list item for the menu. You give it an ID, and then in menus.js, you essentially add to this map, you're mapping the DOM node ID that you just assigned over to the command ID that came from the previous slide. If you're adding a keyboard shortcut, it's even simpler. You're just modifying one file in this case. We just have this mapping of shortcut strings to command IDs. You just add yours there. One note about that is that we've normalized all those shortcut strings to use control. But if you're on a Mac, Brackets is smart and understands that control really means command. You can also have keyboard shortcuts that are more explicitly platform specific. So if you look in that file, you'll see some examples of how to do that. And then there's that third option in addition to keyboard and menu stuff that you don't always want a global keyboard shortcut or a global menu item necessarily. If you have any other piece of UI that you want to trigger a command, it's very simple to just call Command Manager directly and tell it to invoke a command. You give it the ID, and then you give it any arguments that the command requires after that. So that's how commands work in a nutshell. Documents and editors are the next sort of important piece of the Brackets architecture to understand. This is really the heart of the code editor UI. This is what drives everything behind it. So the document object is the model, essentially, and that contains the text for the document. A document corresponds directly to a file on disk. And then associated with that document, you can have one or more editors. And as I mentioned before, editor is really just a thin wrapper around CodeMirror. So it provides the wiring to and from document, and it provides a few more pieces of Bracket-specific functionality, but really the heart of the editor is a CodeMirror instance. Now, I also mentioned earlier that CodeMirror doesn't provide itself a separation of the model from the UI, and one of the consequences of that is that document and editor are not cleanly separated in terms of model and view either. And one of the consequences of that is that document right now is essentially a read-only view of the text. If you want to get the text of a file and just look at it, you can use a document. If you want to listen for changes to the text, you can use a document. If you want to actually modify, mutate the text, typically right now in the Brackets code, you'd actually go get a specific editor and go through the editor to modify the text. And I'll show that in a little more detail in just a second. So usage of document. Here are a couple sort of key things that you can do with the document. You can get the text, as I mentioned. You can listen for the document changing or the file on disk being deleted. Brackets actually automatically, when you focus the window, goes in and checks on disk to see if the files have changed. So you'll get change notifications even for changes made outside of Brackets. That notation there, by the way, is the standard sort of jQuery way of attaching events. So if you have a document object, you wrap it in a jQuery object and call on or off on that object, and you just provide an event handler. Another way that you often use document, though, is simply as an input to other APIs. So a lot of APIs in Brackets that you might want to call for other purposes, they take a document as input. So oftentimes you'll need to get a document, not because you're going to do something directly with it yourself, but because you need to pass it on to some other API. So on that note, how do you actually get a document? These are sort of the top big three ways that you get a hold of a document object. First, if you have a specific editor in mind, often you care about where the user's cursor is at the moment. So you can ask Editor Manager for what the focus editor is, and that'll either be a main editor or an inline editor, depending on where the keyboard focus is. And once you have that editor object, you can always get the document for the editor. If you have a particular file name in mind, you can go through Document Manager. And there are two different methods here. You notice there's a synchronous and an asynchronous method. So if you, because of the fact that the document actually knows the text of the file, that means that if Brackets hasn't loaded the file yet, to get a document, it needs to go read the file off of disk. And that's one of those APIs that we treat as asynchronous. So for that reason, if you're getting a document and you're not guaranteed that it's been loaded by Brackets already, the API for getting the document is also asynchronous because it might entail going and reading the document off of disk. If you know for sure that the document is already loaded, or you don't care about documents that aren't loaded, you can call the synchronous API, which will return you a document synchronously, or if it hasn't been loaded by Brackets already, we'll just return null. One last important usage note about document is that documents are ref counted. This is kind of a drag. It sounds a little bit like we're back in 1990 something and doing C++ code, but it's actually pretty important. And it's kind of a consequence of the fact that JavaScript doesn't have anything like weak references or weak listeners. And we need documents to be a consistent model that's shared by all pieces of the UI that are looking at a document, modifying a document, and listening for changes. And because of that, particularly if you're going to add listeners or hold on to a document for a longer period of time, you need to basically make brackets aware that you're holding onto that document. So this code snippet is basically how that works. At the point when you acquire a reference to a document, whatever API you're using to do that, if you're going to store the document, this is sort of the rule of thumb. If you're going to store the document for more than the duration of a function call, and particularly if you're going to add listeners to it, that's when you need to use ref counting. So when you acquire the document, you add ref it, and that's also the point typically when you'd attach any listeners if you care about getting events if other parts of the UI change the document. When you, yeah. So the question was, if you're working in an extension, do you still have to do this? And the answer is yes. So the rule of thumb is if you're getting a document and you're just going to read the text quickly, essentially do something synchronous with it, like you get it at the beginning of your function call and you're done with it at the end and you're not storing a reference to it, then you don't really have to worry about ref counting. But if you're going to store it in a variable and hang on to it for a while or do something asynchronous or you want to be notified of changes later, anything like that, you need to do a ref count no matter what, so that brackets knows that that document needs to be essentially kept alive. So when you're done with your document, like if the piece of UI that uses this document is going away or whatnot, you want to do your release ref, and that's also the point at which you would remove your event listener. And that's very important to do both of those things. So if you only release the ref and you forget to detach your event listener, or vice versa, you're essentially leaking the document at that point, and that's certainly not a good thing. So with that said, there's also editor. There are some things that you want to use editor for that it just doesn't make sense to use a document for. Things that have to do with the selection state or the cursor position, you really need to single out a specific editor, not just the abstract document. Editor also has some methods for getting pieces of text, like getting the selection or getting a particular line of text without the rest of the document. Some of those methods, like get line text, will probably migrate to document eventually, but they're on editor right now because we sort of lean on CodeMirror for some of that model level stuff. The actual underlying CodeMirror object is accessible through editor right now. There's this underscore CodeMirror variable. And this is sort of an ongoing debate that we're thinking through right now on the brackets team. You know, do we actually want to eventually abstract that away entirely and make it hidden? Do we want to have it be sort of discouraged but still accessible? Do we want to have it be an official accessible thing that it's always okay to go poke at in any way? So we're still sort of thinking through that. One note about this is that, you know, as I mentioned before, document is sort of an immutable read-only view of the text right now. And if you want to make a change, you go through editor. And right now, in fact, you typically go through not just editor, but through the CodeMirror object itself. So replace range is the typical API you'll use for that. It's a very flexible API. It's kind of like array.splice, where you can use it for deleting text, for inserting text, or for a combination of both. One other note about working with editor and CodeMirror APIs is that CodeMirror normalizes all the text to \n, basically Mac Unix style line endings. So even if you're running on Windows, you're not going to encounter CRLF kind of line endings. You can feed those in if you want, but it'll normalize them. Anytime you read text back out, it'll always have symbol \n line endings. So that's actually kind of a nice feature to not have to worry about that. All right, so one last sort of big piece of core stuff that's important to understand if you're going to do almost anything in brackets is the way that we deal with asynchronous APIs. And asynchronous APIs are really all over the place in the brackets code base. And a lot of that comes back to that thing I said at the beginning about how brackets talking to the native app shell APIs is treated as asynchronous. All those APIs are treated as if they were asynchronous. And that kind of has a snowball effect that then any APIs that talk to those APIs are asynchronous, and anyone who talks to those winds up asynchronous. So really, throughout the code base, there's a lot of asynchronous stuff. The way that we chose to tackle that is to leverage the jQuery deferred mechanism, which is essentially a utility that kind of wraps up dealing with asynchronous processes and listening for the ending of them. How many people are familiar with deferred or promise already? Fewer, yeah. Okay, so it's a less heavily used part of jQuery. So let me talk very quickly about how those work, and I'll show a couple examples. Fundamentally, though, the deferred mechanism is just a way to listen for the completion of an asynchronous operation, a particular invocation of an asynchronous operation. So if you're calling an asynchronous API, it will return you a promise object. And that's just basically a token that you use to listen for when the operation is going to complete. So here's a quick code example. You can see we're calling some method that begins an asynchronous operation. You can pass it whatever arguments, and it returns you back a promise object. Once you have that object, you can use the done and fail methods to add handlers for when the operation actually completes. And in that way, it looks a lot like just providing callbacks. I mean, you can see here, it's just providing an anonymous function in both of those cases. One of the distinctions between this and callbacks, though, is that it actually feels more like event handlers in the sense that you can hold on to this promise object and pass it around to other pieces of the code, and they can add their own done and fail handlers as well. And in that way, it feels a lot more like adding event listeners to a DOM node or something like that. And you can also see here that the functions that are handling done and fail, they can get arguments back from the operation. So when the operation completes, it can provide you with a piece of data when it's done, or it can provide you with error information if it fails. So that's basically how to use, from the standpoint of a client of an asynchronous API, that's how you use this mechanism. So the flip side of that coin is if you're implementing an API that completes asynchronously, here's basically how that works. You start out by newing up a deferred object, basically, and that's an object that you use to signal when the operation is done, rather than listening for the completion of it like the client would do. And the way that basically works is you new this thing up, you kick off some asynchronous thing. So in this case, we're saying hypothetically there's some send network request method that runs asynchronously. And so you're providing it a callback here, but that method, it's asynchronous, so it returns right away. So all we really do is new up a deferred, kick off some request, and then return a promise object that's tied to that deferred. You can really think of a promise and deferred as two different interfaces onto the same sort of token object. Promise is an API that only lets you listen for completion, and deferred is an API that lets you signal that it has completed. And then later on, when your asynchronous process finishes, you call reject or resolve on the deferred to signal that completion. And this is where you'd also pass the arguments that get provided to the done and fail handlers. So the names of those APIs are a little confusing, so I put up a little table here to make it a little hopefully more helpful. When you're signaling the outcome of something, you call resolve or reject. When you're listening for the outcome of something, you call done or fail. That can be confusing because done and fail sound kind of like verbs, but really what those methods are is essentially add done listener and add fail listener. One other note about this is that in this example here, this is sort of a different, the actual asynchronous thing going on here is like provided a callback and has sort of a different interface than deferred or promise. Oftentimes, though, when you're implementing an asynchronous API, the thing that you'll be calling in turn is something else that returns deferred and promise. And so there are a number of different ways for chaining together deferreds and promises. It's definitely worth reading up on the jQuery docs or just looking around the brackets code for usage of these things to see how they're used in different circumstances. And one other note about that, if you are writing code where you have a chain of multiple deferred or multiple asynchronous tasks that are sort of similar in nature, like you're opening multiple files or saving multiple files in parallel or sequentially, we have a module called async that provides some utilities to make that much easier to work with. So rather than coding up those sorts of sequencing patterns yourself. So that's sort of the stuff that's really essential to know pretty much no matter what. I have two last little slides here real quick about things that are maybe a little bit less essential but probably still interesting, and I'll just go over those briefly, and then hopefully we'll have a couple minutes for questions. Live development is something that is obviously one of the kind of big headliner features in brackets, and so it's a lot of interest in how that works often. And basically, it's pretty simple. We have brackets, and we have the Chrome process. Chrome has a remote debugger API that just basically opens up a socket and accepts JSON. So brackets opens up a WebSocket, your standard HTML5 WebSocket, and connects to that Chrome socket and sends JSON strings back and forth. And that's pretty much all there is to it, with one little wrinkle, which is that the Web Inspector or Developer Tools UI in Chrome talks over that same JSON API. So even though it's actually running in the Chrome process and it could theoretically be calling native methods directly, it actually uses that same exact socket connection. And the core remote debugger API, it only accepts one client on that socket at a time. So as a consequence, if you're connected to Chrome with brackets and doing live development, and then in Chrome you open the Developer Tools UI, it'll kick brackets off the connection. And similarly, if you have a page where the Developer Tool Web Inspector UI is open, and you try to connect to brackets, it can't. We have to open another copy of the page to do that. So that's a limitation that we're talking to the Chrome team about, how we can alleviate that situation. Last little note, file I/O if you're working with documents and editors, typically the file I/O has kind of already been taken care of for you. But if you need to load files off of disk or save files or whatnot for any other reason, we do have this file I/O API that you can use. We have a native file system module, which is essentially a partial implementation of the draft directories and system W3C spec, which I've always thought is kind of an ungrammatical sounding name for a spec, but it is a draft, so you never know. They could change that. And so there's some core objects in there that are useful, like file entry, directory entry, file reader, file writer. That's basically what you would use to do file I/O at a lower level. If you poke around enough in brackets, you'll notice there's also, excuse me, there's also a lower level API called brackets.fs, and you should avoid using that. Sorry. You should avoid using brackets.fs and prefer to use the native file system module. Brackets.fs you can think of as essentially an implementation detail. One other note about file I/O, if all you want to do is just load a file off disk and get its contents as a string, we have a read as text utility that's even simpler to use than having to go through all the native file system APIs. So that's been essentially the grab bag of different topics, some really, really essential, some may depend on what you're doing, whether they're useful or not. Again, a lot of this stuff, I know I sort of flew through this. We can take questions now. If we run out of time or if you come up with a question later, we can always answer questions at the hackathon later today on our IRC channel, on our Google Groups mailing list, et cetera, et cetera. So we're always open to talk to you about stuff like this. Oh yes, yeah, and in terms of extensions and how those are packaged, I sort of didn't talk about that at all, but one of the I guess NJ yours, yeah. So one of NJ's talk will cover that in more detail. Any questions?
I have a question.
Yeah.
So in the let's say I'm creating a RequireJS module and I want to access jQuery. Do I have to import jQuery?
No. So the question was, if you're using something like jQuery, do you have to import that into your module? And the answer is no. So the pieces that we use that aren't packaged as RequireJS modules already, things like CodeMirror and jQuery, those basically get imported into the global namespace. So those are accessible from all modules. Any other? Bruce?
What happens if two pieces of code register for the same command?
The question was, what happens if two pieces of code register for the same command? I think right now the most recent one wins. I'm not sure if we even issue an error warning. We are just sort of at the beginnings of trying to make our extensibility story nicer and cleaner, and I imagine that's one of the things that we will clean up, though. And it's the same thing for menus and keyboard shortcuts. If you add the same keyboard shortcut twice, one of them will win and the other one won't, and you don't really get any warning at this point.